Okay, so in this final video on multiplying polynomials, we're going to deal with something that's not exactly multiplying, but you're going to see that the way the problem works out, it's going to turn into multiplication. So what we're going to look at is we're going to look at polynomials that have been raised to a power. So how to deal with exponents in polynomials in the same problem. So that's our only learning objective, is to just simply be able to take a polynomial and raise it to a power. All right, so with that said, let's take a look at an example. So here's example number 1. Let's take the polynomial 2x plus 1 and let's square it. Okay, 2x plus 1 and we're going to square it. Okay, now we have talked a lot over the first couple of weeks of our class about when you can distribute things and when you cannot distribute things, and we have revisited over and over and over again that this exponent cannot be distributed in this particular problem because of the plus sign. There is no distributive property for exponents with addition. That doesn't work. And so the only way to do this problem that we will really learn, we will maybe learn a little bit of a shortcut next week, but really this is what we're going to do right now, really is the bottom line. And that is to think of this based on the definition of squaring as being a 2x plus 1 times itself, because that's really what squaring means. Squaring means multiply something by itself. So as long as you think of it that way, then the rest of the problem just connects very nicely with what we've been talking about in the previous videos on how to multiply. And you know by now that you can multiply this with FOIL, but I'm going to choose to multiply it with a double distributive process. So I'm going to take this first thing and distribute it into those parentheses. So I'm going to get a 2x plus 1 times this 2x. And then I'm going to get a 2x plus 1, plus 1 times this 1. And I'm going to add those together. And so that's the basic distributive, or first half of my double distribute. Now for the second half, I'm going to distribute the 2x into those parentheses, and I'm going to distribute the 1 into these parentheses. So a 2x times 2x gives me a 4x squared. A 2x times 1 is 2x. And then when I distribute 1, well, anything times 1 is just itself. So I'm going to get a 2x when I distribute it here, and when 1 times 1 is just 1. Now I can combine together my like terms, and I've got my final answer. And so this is the basic process. As I said, there is a little bit of a shortcut to this. It's not much of a shortcut. We'll talk about it very, very briefly next week. But I think when we get to that shortcut, you will find most of my students find that they prefer to just simply do it this way, that the shortcut, it's not worth the time, energy, and effort that is required in order to memorize the rule. Okay. Some of you will disagree, and some of you will choose to memorize the shortcut rule. But basically, this is our process. All right, one last example. Let's take x minus 3 and let's raise it to the third power. X minus 3 to the third power. So again, I cannot distribute. I have to think of this based on, x minus 3, based on the definition of a power as being x minus 3 times itself. So that there's 3 x minus 3s. Okay. Now, the last piece of this is, remember, when we multiply, you can only multiply 2 things together at a time, and you multiply from left to right. So what I'm going to do is I'm going to multiply those 2 things together first using this double distribute process. And this last x plus 3, I'm going to just let it sit there for a couple minutes while I work with this. Okay. So when I distribute the x minus 3 to the x, I'm going to get this. And then I just always put in a plus sign, and I'm going to distribute this to the negative 3. And then there's still just going to be this x minus 3 hanging out at the end that we're not going to worry about right now. So it's all of this stuff times x minus 3 is what it is. But that's it, just hanging out at the end. We don't really have to worry about that. And I just keep going. Now I'm going to distribute this x here. So x times x is x squared. X times negative 3 is negative 3x. Then I'm going to distribute this negative 3. Negative 3 times x is a negative 3x. Negative 3 times negative 3 is a positive 9. So I've got all of that stuff times that -3, or x minus 3 is just hanging out at the end. Combine together my like terms, and now that's a 6x. Now what I have to do is I have to distribute that final x minus 3, okay? So you can choose to do this either way. You could distribute this great big thing in to the small one, or you can take the small one and distribute it into the big one. It doesn't matter. We know when we multiply 2 times 3 is the same as 3 times 2. It doesn't matter what order you do it in. I'm going to choose, I think, to just keep working left to right, just because that's how we've done every problem so far. And so I don't really see a reason to change it. So I'm going to take this whole thing and distribute that into the parentheses. So that gives me an x squared minus 6x plus 9 times the x. And then I just always put a plus sign. And then I'm going to have the x squared minus 6x plus 9 times the -3. Okay. And then to finish, I'm going to do the second half of my distribute process. So that x I'm going to distribute to those three things. X times x squared is x cubed. X times a -6x is a -6x squared. X times 9 is a 9x. And then I'm going to distribute that -3. So -3 times x squared is a -3x squared. -3 times -6x is going to be a positive 18x. And -3 times 9 is going to be a -27. So now I can combine together my like terms. And then once I do that, I'm going to be all done. So there's nothing to combine with the x cubed. I've got a -6x squared and a -3x squared. So together that gives me a -9x squared. I've got a positive 9 and a positive 18. So together that gives me a positive 27x. And then last but not least, I've got -27. Okay, so if I have, well, anytime I have an exponent, I just change it into a multiply problem. So squared is the thing times itself, cubed is the thing times itself, so that there's 3 of them. And then I just go through and I work through the multiply process and get myself down to the answer by doing that multiplication process as many times as I need. All right, so that's how we're going to handle exponents. Thanks for watching this video. Have a good one.